Hi, my name is Haben Blondeel, and I will present to you the results of a research project called UnderSCORE, where we assess the need for an understory decision support system for temperate deciduous forest management. So we know that numerous decision makers have an interest in how forest biodiversity will change in the future, and especially in light of global environmental change. So decision makers can make decisions for their own management incentives, for instance, managing for people, such as for recreation, or for production, or for biodiversity conservation. And now we have these large policy incentives that would adhere to such visions, which are, for instance, the best biodiversity assessment, or the BOM Forest Restoration Challenge, or the UN Strategic Plan for Forests. And so to adhere to these programs, decision makers, and especially strategic decision makers, the ones that have to take into account long terms and broad spatial scales, they can rely on literature, conversations with colleagues, or their own education, or another person's education via expert knowledge, experience, or on decision support systems. And this last one is interesting because this is a complex system that uses a user interface. It has a simulation tool. It uses database management, and it's also quite dynamic. And it is dynamic because DSS, or decision support system, requires models to run. But currently, those models focus heavily on trees, and especially in the temperate forest biome. And there are numerous aspects that could be taken into account, such as this figure is showing. And one aspect is the understory. And the understory is an often overlooked component of the forest ecosystem. But it is important for biodiversity and for ecosystem functioning because it can contribute to the total above ground litter production. It is also the layer where tree regeneration is passing through, so it can actually hamper tree regeneration via competition. But it can also contribute to nutrient cycling because the leaf litter in these herbaceous plants is often of higher quality, and because the leaf area can be quite extensive. It's also important for the forest evapotranspiration. And so the goal of our study was to ascertain whether decision makers, and especially these strategic decision makers that take long-term decisions, if they consider the forest understory while making decisions in light of environmental change and management plan. And so we've sent out a questionnaire to poll the targets, challenges, and motivations of these decision makers. And we've not prompted them by telling that this is an understory focused study, but we have rather inconspicuously entered some understory variables within lists to see whether they are considering this layer while making decisions. And when we look at the priorities, so the results of our study, we see that the management challenges, that mainly climate change, biodiversity, and regeneration are really popping up as very important topics to consider in the future. So rising temperatures, droughts, disturbances, those things are high up on the challenge list. And on the target list, we see biodiversity values, adaptation, mitigation, tree identity, and regeneration. These are the top 5. And then when we look at the final, the highlighted item, the understory is rather inconspicuously in this list as well. So it was not identifiable as very important. But we had a follow-up question where we straightly asked, do you think the understory is an item to take into consideration for management? And then we have a shift from important to very important. But of course, this is a bit of respondent bias probably. So we conclude from this that the understory can be merely seen as important for forest management decision makers. And then we also asked what the sources are that our respondent pool uses. And we see that DSS is not very popular because around 60% is not using a DSS. But mainly other sources are used, such as experience, colleagues' knowledge, context, literature, and so on. What was interesting in this finding and in all findings that we have presented here throughout is that there was not very much difference in the occupation of the respondent and whether this had any effect on their answering patterns. So these are really broad, generalizable patterns that we are showing here across occupations. And we also in tandem reviewed the literature, and we found no decision support system with an understory focus in temperate forest biomes. So that begs the question, is there a knowledge gap that needs to be closed? Because we know that this forest understory is an important layer for biodiversity and functioning, but is this knowledge not trickling down to decision makers, and can it help with attaining their management objectives? And so then we conclude this problem in 3 points. So first, our questionnaire has shown that decision makers indeed focus on biodiversity, climate change, and forest regeneration. And then second, the studies at our lab here in Ghent University, but also beyond, show that the forest understory really has a functional role, but there's also biodiversity reservoir. Up to 90% of the vascular plant species are represented in this layer in the temperate forest biome. So this is really important also for other species such as pollinators. And then the third item is that we found an apparent lack of existing understory decision support system, while there is also clearly a market for this, because at least 35% of the respondents in our questionnaire used DSS in making management decisions. And so when putting these 3 items together, we asked, is there a need for a tool to predict understory dynamics in a changing world? And we think so, that there is really a need for such a tool, because the understory is quite an important layer, especially with attaining goals that are related to biodiversity and climate change, forest regeneration. So we have put these items together and we have tried to make a proof of concept decision support system called UnderSCORE. And our target group for this DSS was EU level policymakers, so really the strategic policymakers in Europe. And we've included scenarios related to environmental change, and these are related to nitrogen deposition, so business as usual scenario, and the one formulated by the Clear Air Outlook, and then also a climate change scenario, so shared socioeconomic pathways within the IPCC assessment report, the latest one, so AR6. And our model that we used here is a purely statistical model. It is really as a prototype to show that these patterns could be predicted in several understory properties. And we have 2 databases that are backing this up, which is forest replot and also past forward resurveys as training data. And this is really work in progress. So it is for others to build on, and that we also invite feedback from you, hopefully a user, on this website, which is linked here below. And the prototype underscore DSS is also provided there. So I invite you now to let's have a look together on this underscore DSS, which is provided here. And so the underscore is a proof of concept understory decision support tool. And let me first briefly explain the name a bit. So underscore really emphasizes or underscores the importance of the understory in taking management decisions, and especially in light of several environmental change contexts, so as we provide here, and also for management incentives, which are provided here via the canopy closure. And underscore provides easily comprehensive scores or metrics of the understory, of which we have 4. And so I'll start the simulation by selecting a region, and I'll select Flanders because I live here in the region of Ghent, in the city of Ghent. And we have some environmental variables that are put into the model. So we have mean annual temperature, we have precipitation, nitrogen deposition, also pH, so soil acidity that is taken into account. But these values are really the average across the region, and also for all these other regions here, which is the NUTS administrative regions of the EU within the temperate forest biome then. We only have the average conditions. So we cannot predict for any particular site. It's really to get a handle on what the averages within these regions are doing. And the same for these trends. These are average properties that are propagated within the future. So we can then also select a scenario. So let's select clean air outlook for the nitrogen deposition. Then we see that this value has shifted. So there's a target here that is linked to policy incentive for that particular region. We can also change the climate change scenario. So here, the SSP2, let's pick this one, the middle of the road. We see an increase in the temperature. And then we have the output variables here. With these input scenarios, there are also always a narrative which explains and redirects also to the important links that you can find this policy background on. What is important here is that as a forest management decision maker is that you can also change the level of the canopy closure. And this is really the key that a decision maker has in hand to try and mitigate effects of nitrogen imposition and climate change. For instance, if we would transition from a closed forest to an open forest, as here, we see that there are some changes in the output. The richness will remain stable, so the number of species will not change, basically. The cover as well, that would also remain stable. The amount of woody species would remain flat, but we see a sharp decline in the amount of specialists, so the shaded species, the species that love shaded conditions. Let's see what happens if we change this forest type to closed forest type. Well, then we see that this decline is much less happening. This is important for biodiversity conservation because these forest specialists are often the vernal species, the ones that are flowering in early spring, and are often of conservation concern. We see also a sharp increase in the amount of woody species with a closed canopy, and no real change with the amount of species and the understory vegetation cover. And so if we put these items together, we get a quite good idea of what a compositional shift in the forest could occur. Of course, this underscore DSS is not limited to Flanders. We can also see what happens in another region. Let's pick here, Brandenburg. We can change into a more severe scenario, for instance, fossil fuel development, and then we can see, of course, what is happening within these scenarios. And what we really want to emphasize here is that the forest managers can mitigate effects of climate change by choosing a different scenario. So from a closed forest, you usually would see that there is in the model a lesser decline in the amount of forest specialists. And if we keep forests open in the future, then we will lose more of these specialists. So I hope that with this message, I have sparked an interest in our underscore DSS. So I invite you as a viewer to check out the website, also the tool link to this DSS on the website of underscore, so that we can maybe get some feedback from you in terms of the working of this model and what would be interesting to use in the future as well. So thank you for your time, and I hope you have enjoyed